Hi guys, welcome to lesson 6 of Fusion. Now we're going to talk about some topics that some of you guys discovered in the previous in-class assignment. But we're going to get into the details of those. And the first one being is the pattern. Now, there are different pattern types in Fusion. If you go down to the menu under Create, you will see the pattern writing. Then you will see a sub-menu where it shows you rectangular pattern, circular pattern, pattern on path, and geometric pattern. Now, we're going to talk about all of these, but as you can see from the menu, the geometric pattern has this extension logo on the beginning. So this one needs the extension to be enabled to work, but we'll get to that later. Now we're going to start with the rectangular pattern. But before we get into the patterns under the solids, we need to talk about the patterns under the sketch environment. So to do that, let's get into a sketch. Let's do a sketch on the right plane. And let's start by drawing, let's say, a circle. And I'm going to draw the circle anywhere, any size for now. Then, when I'm in the sketch environment, if I click Create and go down, you can see there are two patterns that we can see under the sketch environment. Now, the third and the fourth one are only available in the solid environment. It's not in the sketch environment. So there is a slight difference. And there is a difference when you're working with patterns under sketch and patterns under solid environment. It becomes, especially if you have a large pattern, it becomes a problem in the sketch environment, and I'll demonstrate that. Okay. Now, let's do a circular pattern with this circle. Now, as soon as I click the circular pattern, it's asking me two things. It's asking me the object first, which is my circle, and it's asking me a center point. And for this example, I'm going to click the origin point. Okay. The origin point. Now, as soon as I click that, Fusion is giving me an example preview for 3 items. Now, the quantity 3 is including your first item as well. So it's the total quantity. It's not the extra, okay? Now, if I were to increase the quantity, you can see in the sketch environment, I'm getting more and more circles as a result. And it always includes your original item. Now, the thing to note is the distance between these items, and in a circular pattern, that means the angle from the origin between these items are always the same, because the distribution in the panel here is selected as full, okay? Now, if I were to change that, if I were to say partial, you can control the distribution according to the angle that you specify, but the distance between them will still be the same, but it will not complete a full circle in terms of a circular pattern, okay? So I can say, actually, let's type it. Let's say half a circle, which is 180 degrees. I can say, yeah, I want a pattern on 180 degrees with, let's say, 12 of these items, okay? And that's fine. Now, there's another thing that you can do, which is actually quite nice to be able to do this in the pattern dialog, is the suppression. Suppressing means to get rid of the ones that you don't want in this pattern. Let's say, as you can see, there's a check mark in all of the boxes, but I can say I don't want this to be included in the pattern, and I don't want this to be included in the pattern. So when I say OK, see, those will be missing. Okay? Now, there's this small icon appearing that it's showing me there's a circular pattern here. And if I double click that, I can go back into my pattern dialog. But if I click suppression, unless I click suppression, I will not be able to see the checkboxes. So I have to click suppression again. Then I have to select the checkboxes to re-enable those. Okay. Now, if I were to move these, if I were to make them smaller or bigger, you can see it affects everyone because they're in the pattern. Okay. If I were to select and move one of them, okay, like that, see, it affects everything. Okay. So the pattern tries to adapt to what I'm doing in the sketch environment. Okay. Let's say cancel. And if I go back, edit it, there's another one that you can see under the partial. It's called symmetric. Now the symmetric is quite nice because it gives you, actually let's do this. Let's go back to, let's say something like 5, okay? And say okay. And re-edit so it clears the screen. Now you can see that when I click symmetric, I'm getting the same amount of circles and the same distance from my original item. See, this is my original circle, and I have 2 on each side, which moves according to that central item. Okay. See, I can increase the number, and both of them increase, but you have to watch out. If the number is an odd number, not an even number, you'll get 1 more on one side, or we can say 1 less on one side. So even numbers work better, so keep that in mind. Let's do a full for now, and let's click OK. So now let's say I want to extrude these. Okay, let's say I go into solid and I say extrude. Okay, what I have to do is I have to either do this. Okay, I have to create a selection of all of the items. Okay, or if it's a complex model, let's say I can't do this because I will be selecting other things, or I can't do this. Okay, what I have to do is I have to go back and select each one. Okay, now when you have 10, that might not be an issue, but when you have, let's say 100, selecting them each one by one, especially if you know they're going to be the same thing, doesn't make sense. Okay, so there we have it. We have our 10 extrusions in a circular pattern. Now let's create a new design. Oh, by the way, if you were to move these, try and move them, let's say do it like that, okay, you will see that they will not move. Okay, if I go into body and select move, okay, then you can move it. You can't pull it. Okay, you have to go into the bodies, right click, select move, then you can move it. Okay, so when you're in the sketch environment, when you move them, they adapt to your movement. Okay, let's go back to the sketch environment. Let's say edit sketch. When you move them here, they adapt, but once you turn them into an extrusion, okay, let's say I say like that, I say okay, yeah, they move, but as you can see, the move command is giving me an error now. so I have to delete that. Let's actually change it back so they don't intersect. Something like that. Okay, finish. Now I can move it again. But it will not adapt once you turn them into a solid as such. They will adapt when they're in a sketch. Okay, let's create a new design. This time, let's do the rectangular pattern. Okay, so for this, I'm going to create a small square, 10 by 10. Okay. Then I'm going to go into create and say rectangular pattern. It's the same thing. It's asking me for an object, but this time it's asking me for a direction or directions. Now let's click the object. Okay. Now you can see these two arrows. Okay. This is telling you that you can do a pattern in two axes. So this is, let's say, my first axis, and this is my second one. Okay. Now, as soon as I do this, you can see I have 9 squares. Okay. Now, the important thing to realize here is I didn't select the direction, I pulled the arrows, but I could have just as easily said my first direction is this, okay? Okay. And my second direction is this. Okay. I could have selected a direction using my square. Okay. Now, the direction flipped, as you guys can see, you can easily change that by giving it a negative distance, okay? You can give it a negative distance, and that's fine as well. But you have to realize that the extent is controlling my distance. So the distance between each of the squares is not calculated right now. The distance that is calculated is from the beginning. Actually, let's flip this one so you guys can see it easier, okay? Because the grid has numbers. You can see that it's at 50, right? Minus 50. And my beginning is at 0. So what it's doing is it's calculating the whole thing and putting pieces between it. So if I increase it, if I say 4, the total distance doesn't change. If I say 5, it's still between 0 and 50. Now, this doesn't always become useful. Sometimes what you want to do is you want to control the distance between the items, okay? Now, the nice way to do that is go into distribution and select spacing instead of extent, okay? When you click spacing and give it 50, you will see that the distance between each one becomes 50, okay? Most of the time, this is more useful. This time, I'm going to say, I'm going to keep a very low distance between them. I'm going to say 11 for this one, and minus 11 for this one. Okay, so that's a 3 by 5 rectangular pattern. Okay, so we have a 3 by 5 pattern with 15 of these rectangles. Now, there's another way that you can modify this. You can say, I want a symmetric, okay, just like in the circular pattern. And I want a symmetric on one axis, but I can also have symmetric on both axes. So this means your pattern can generate from the center, okay? The even and odd numbers still create an issue here. You have to watch out for this. When I select 6, it puts 3 on one side, 2 on one side. When I say 7, it puts equal amount on each side, okay? So now we have 35 rectangles. Let's say okay. Now, let's say I want to extrude these, okay? I can always select them one by one. It becomes cumbersome. Let's do a multi-selection for now. Let's extrude. Now I have this, okay? Now you have to realize we're still in the same component, so we have 35 bodies in the same component. Let's say I want to press and pull this, okay? I can't, okay? They all move at the same time. Let's cancel that. Let's say I want to extrude one of them, okay? Then I can do it, okay? So when you press and pull, because we're in the same component, the bodies move one by one, okay? But I can extrude them. So with this, I can create multiple extrusions as such, okay? I can say do that and do this, for example. So I can do this, but with press and pull I can't. See, after I extrude it, when I click press and pull, it moves by itself. So what happened behind the scenes, what happened is they stopped working together as a pattern. Once you extrude it, the pattern is broken. But if you go back to the sketch and edit it, it's still a pattern, okay? So if you try and move one of them, unlike a circular pattern, it doesn't work like that. Let's double click it. Let's go into edit pattern. I can still change the pattern, okay? And my changes will still be applied. Okay. Now you guys need to do some experiments with this to get used to it, but it's very logical. So now this is coming from the sketch pattern. Now let's do one in the solid environment. Actually, let's use one of these as our solid environment pattern object. So let's go into create when we're in the solid environment. Let's say circular pattern. Now, it's the circular pattern opens up a new tab on the right hand side. In the new Fusion versions, we can change while we're inside of the circular in the pattern dialog. So whichever one you open, it's going to open up the same dialog. That's why I only have the rectangular pattern in my taskbar, because it opens up the same dialog, as you can see. Okay, I can just switch to circular pattern here. Now it's asking me for an object type. As you can see, you have all types of objects that you can pattern, and you will see that features will be very useful in the future. But for now, let's select bodies. Let's select this object, and for an axis, let's actually select the edge of the object itself. Okay. So let's say okay. You can see that you can create a pattern from a solid, just like you do in the sketch. Okay. Now, this new bodies are added, so they're nothing special. And if you go and select the original body that you used to copy, okay, and move it like that, you will see that the pattern will not follow, okay? It will stay there, so they're not attached, okay? Now, let's go back to our circle. for this example. And let's create an axis. Let's create an axis. Let's create an axis through a cylinder. Okay. You can see the cyan colored axis. Okay. And let's do a circular pattern with one of these bodies using this newly created axis. And let's increase the number. Something like that. Just for the sake of the example. Okay. So now we have multiple bodies, and you still can't move the bodies we talked about. And if I move my original one, right, it still doesn't follow. Okay, so in the solid modeling environment, the children, let's say, that are formed with the pattern are not attached to the original object. So keep that in mind. If I were to move the axis, which, let's say, do something like that, okay? This is a warning. Nope, I don't want to configure. I want to edit feature. Okay, if I go and select that, for example, say OK, you can see that the pattern is broken. Okay, so you have to go back and do another pattern. So once the pattern is formed, they're all separate bodies. Okay. Now, let's do something different. Let's do a component. So let's do a new design. In a new design, let's say new component. I'm not going to give it, let's give it a name actually. Let's say part. Let's say part 1. Okay. Now let's model something very simple. On the top, let's do a 20 millimeter cylinder with a height of 35. Okay. Now, this is a component. I'm in the component, as you can see. It's selected. I'm going to go out of the component to the parent. Okay. Now I'm going to say, I want to pattern this. I want to pattern a circular pattern using this. Actually, I should first create an axis that I want to turn around. Okay. Now, let's go back to the top. While we're in the parent, let's create a sketch. Let's put a point. Let's create a sketch. Let's put a point here. Okay, let's finish the sketch. Now, let's create a circular pattern with components selected. Let's select the object, which is part 1. Let's select the axis. Wait, I forgot something. I forgot to define an axis. A point is not enough when you're doing solid patterning. Okay, in a circular pattern, if you're in a sketch, a point is enough. Okay, but when you're in the solid environment, you need an axis. It needs to be in the 3-dimensional space. Okay, so let's create an axis. Axis perpendicular at point. Okay, let's select this. Oh, no, not that one. That's the wrong one, right? We want axis perpendicular to face at point. So we need to select the top face and select the point. Select the top face. No, we're selecting the wrong thing. We want to select the face. Okay. So it's perpendicular to this face at this point. Okay. So we have our axes. Now, let's create a circular pattern from components. Let's select, you can select the object or you can select the part here. And let's select the axes. Okay, now we have 3 components. Let's say I want 5 components. Okay, now you can see Fusion has put 4 new components after my original component. Let's see what happens when I move one of them. Okay, you can revert back to position. Let's see what happens when I move the original one. Okay, let's see what happens when I press and pull. Okay, let's see what happens when I press and pull the outside. Okay, cancel. Let's see what happens when I extrude. So there is a difference. As you can see, if we were doing it in the body, in a single component with multiple bodies, when I use the extrude, not all of them extruded, right? When I use the extrude in multiple bodies, only one of them extruded, the body that I selected, right? But when I'm doing it in the component environment, when I say extrude, okay, all of them extrude. What happens if I extrude this one? All of them extrude. So it's not only because I'm extruding the original item, they all get affected. So there is a relationship, okay? There is a relationship between all of these components in terms of their sizing that is coming from the pattern, okay? It's coming from the pattern, okay? Now, so this is what happens when you do it in the solid environment. The same thing is applicable to the rectangular pattern, but we have 2 different patterns in the solid environment. We have pattern on path, which is actually quite useful. And to demonstrate that, let's create a sketch while we're in the parent. Let's do, for the first example, let's do a spline. Okay, something like that, basic. Let's say finish. Let's go into pattern, pattern on path. It's selected. It's asking me for the object type. And because I'm in the parent, I want to use the component. I'll select component. I'll select my object. Then I'll select my path. Okay. Now you can see that the path that it's showing me is a little bit different than what the original path looks like, okay? Now, let's see. How many do we want? How many do we want? Okay, let's do this. Okay. As soon as I pull the arrow, I get my quantity. Because if you don't do that, if you just select pattern on path, component, object, and path, you will not have the quantity here, okay? You will not have the quantity. To get the quantity tab, all you need to do is pull on the arrow a little bit, and as soon as that, you'll get quantity. Now, remember, I have extent selected, so I can go back to my stop point, which is, let's say, this. Then I can increase the number. And this last one will not change in place. The place will stay the same, but I can fill in between. But if I want to control the distance between them, I need to select spacing, and I need to enter the spacing between them, okay? Let's say 40, okay? 40 millimeters between them, okay? Now, we talked about this line in my path and the other center line of the path is not the same. If I select path direction, you will see that it will become an offset. So if you want it to follow the path with a certain distance, you have to select path direction. If you select identical, it will try to follow the path in terms of what it understands of the path, especially how your path is configured compared to your object. So let me show you. Let's bring the path into the center of the object. Let's say cancel. Okay. Now let's bring the path to the center of my object. Let's say pattern on path again. Select components, select object. Okay, then select the path. Let's pull the arrow a little bit towards the end. Okay, now in the identical, as you can see, because my path is at the center of my object, I don't see the dotted line of the estimated path. I see my actual path. If I select path direction, you will see that the path direction is exactly on my path. Okay? So keep that in mind. Where your path is in relation to your object is important. Now we're going to do this with a rectangle as well, which it will show you what I will show you what it means more clearly. Let's say OK. So I have these 3 objects on the path. Now let's create a new design. And for this design, I'm going to do it with bodies. Let's create a top. Let's create a very thin rectangle. Let's say OK. Extrude this. It's like a domino. I guess you guys all know what a domino is. Let's say this is a domino. Okay. Now, that's my body in my single component. Now, I'm going to go back to the top again. I'm going to create a sketch on the top plane. I'm going to select spline, and I'm going to find the center of the object. How am I going to do that? I can't do that. Okay. Then I can do it, but for this example, let's do it with the corner. Okay. I'm going to create a path that is something like that. Okay. Let's see. Finish sketch. Then I'm going to say rectangular pattern in solid, but instead of component, I'm going to say body. Select my body and select my path. Okay. Now, even though we're in identical, okay, let's go back, because we're using extent, let's go back to that and increase the quantity. You can see that they all are looking at the same direction. So the rectangular prism isn't rotating according to the path. Okay. Now we saw this in the sweep feature, right? In the sweep, we had the same thing. So this is the same exact thing. Okay. But once I select path direction, it's adapting to the angle that I started with. Okay. So the path direction is adapting. Okay. So this depends on what you're trying to do, right? Sometimes this is what you want. Let's say you're making cooling fins on an aluminum extrusion. You're making a radiator for a house. This is probably what you want. But let's say you're making something more complex, like the outside of a building. You have some aesthetic ideas. Maybe this is what you want. Okay. So when I select OK, I get this. So you can create cool stuff with this. Okay. Now let's move our path to the origin of the object. How we're going to do that? So we have to get rid of this constraint first. I select the constraint, I press delete. Now I have this. Then I need to find the center point of this rectangle. But I can't select anything on the rectangle. So what I need to do first is project the top of this rectangle, then create a diagonal line, turn that line into a construction object, then pull this dot towards the middle of that line. Okay, see that small triangle? That's the center line mark. So I do that, I have my center point on this rectangle. Click finish, and as soon as I click finish, the pattern updates itself. Okay, so depending on what you want to do in your path pattern on path, you might need to change the location of your path. Okay, so that's identical, that's path direction. Okay, all right, let's click OK. So this is what we have. Now let's create another design. This time I'm going to create a box. I'm going to create a box like that, something like that. Okay, now on this box, and in many products that you see, you have air vents or sound holes or stuff as such, and they're usually created with geometric patterns. Okay, as soon as I click geometric pattern, I get this. It says this is a part of the design extension, so I need to enable it. So I go into access options, I start my access. Okay, I have 30 days, then I can redo it. Okay, I go into pattern, select geometric pattern. Okay, it hasn't been applied. It's not that fast, I guess. I can always check my extensions here, right there. Okay, it says active, access enabled. Let's see if it's been applied. Okay, I just got this, so it should be applied now. Okay, now you can see the icon has changed into its regular icon. So I click geometric pattern. Now, usually, if you have nothing selected, what it will do is it will ask you for a face. Okay. Actually, before we do that, let's create a fillet here, so we also have a cylindrical face, a round face. So you guys can see that as well. Let's go back to our pattern, geometric pattern, and let's click the cylindrical face. Okay. Now the next thing that you will see is the object type. Okay. Now the object type is important because most of the time you don't need a custom. You actually, what you will see is cylinders, for example. Okay. Now you're seeing many silhouettes of cylinders that have been applied to my face. Now the next one, the next dialog, the object size, tells Fusion the sizes of these cylinders in terms of diameter. So let's say 2 by 2. Okay. These are 2 by 2. Now, why do I have 2 size limits? Because you can tell Fusion to create sizes in a range. So you can say, I want 2 to 4. And that is controlled by the distribution type, and we'll get to that. But in this example, you can see that the silhouettes of these cylinders that are in the middle are 2 millimeters, but as I'm approaching the edge, they're becoming bigger. Okay? Now, what if I wanted the center one to be bigger? So I can change my size limit. Size 1 to 5 and size 2 to 1. So I get this. Now, what if I don't want the ones on the edges? I don't like the ones on the edges. I can say, go down below. There's a clear parameter. I can say, clear that, so it gets rid of the ones on the edge. Okay. Now this is looking more and more like what you would see on a Bluetooth speaker, for example, right? So this is what we have. The spread tells Fusion how it's going to change the ratio between the limit, size limit 1 and size limit 2. Okay, so if it's in the center, there's a good spread, an equal spread from one object to the next. If you go towards the positive, you will see that the center one is bigger, but you will get smaller much faster. And if you go reverse, it's the opposite, okay? So you will get smaller much slower. So you should definitely play with these. Now, this is the important part, the distribution type. Now, as you can see, my cylinders, even though they have different sizes, look like they're a rectangular pattern. But I can change that. I can make that into a triangular pattern, okay? This might be more recognizable in some products, right? I can make it a hexagon pattern, okay? I can make it a circle, looks like a star, and I can make it radial, okay? Now, if I were to move this out a little bit, it will look much better, so they don't intersect. Now I can increase the quantity. I can say, let's make it 20, or I can pull the arrow, okay? Now, if it's too much, you will see these intersections. Now, there are some things that you can change. You can also of course, change the size limit, or you can change the quantity. Okay. Now, let's go back to the rectangular. You can see that the cylinders, in terms of their normals, are following the face. Okay. Now, this is coming from the orientation. You can change that to parallel direction, but in a face as such, this will not work. Okay. I can say choose this as the line, as the parallel direction line, and they will look a little bit weird. It's not that it's not useful. There are some use cases for this, of course, but for this example, I want them to follow the face. Okay. Now, there are some fine controls that you could use. That's the U distance and the V distance. Now, the U and V actually follow the X and Y naming scheme in terms of coordinates. So if I say the U distance should be 8, okay, you can see that the distance between them in terms of the horizontal opened up a little bit. So I could go back and say 5, okay, so it's closed up. The same goes for V. I can say 10. You can see it opened up, and that's very similar to the Y direction, right? Where I can close them down back again. Okay. So that's that. Now, when I'm looking at this, I'm seeing that the middle part is a little bit too close. So I'm going to increase the spread a little bit. Okay. Actually, a little bit more, maybe. Yeah, something like that. So there is some material between these, right? Okay. Now this U and V alignment changed because the U and V alignment changed equally from top to bottom because I have the U and V alignment at the center, but you can also use right and left, okay? So you can control how the U distance is applied in terms of how it's moving on the face. So if I select aligned left and give it an offset of 5, you'll see that it's only applying it to the right side. So we're keeping the left side. So if I say 10, okay, I'm applying first to the left side. Let's go back to 5, and let's go back to the center. Okay. Now the perimeter offset, when I say clear perimeter, I can control how much it clears, by the way. I can say 5 to make it 5 millimeters from the edge. If I uncheck that, it goes away. So I have to keep that. I have to first select clear perimeter, then I can put in an offset. And as the last thing that you should do is the operation type. Now, if I say new body, it's going to create all of these cylinders. And let's do that. Okay, let's do that. So I have these multiple cylinders. Okay. That might be useful for a scenario. We could do something like this. We can select fillet and hide the first body. Select all of them. Apply 0.5 millimeter fillet. So we soften them and we can open it up. So it looks like I don't know, an anti-slip surface. Or what we can do is we can shell our product. Okay, created a shell. Then what we can do with this is change the placement of the shell so it goes behind the pattern, so it doesn't go away when we edit the pattern. And instead of a new body, we can say cut. Okay. And when we do that, we can create openings as such. Now you can see that these last ones were a little bit towards the inside, so the solid wasn't cut properly. Let's edit this. Okay. Let's do square. Let's do a square. Let's make it a little bit bigger. Actually, let's make it, or let's open the distance between them a little bit. Let's say 6. Okay, that looks okay. Let's click OK. Yeah. Now, if I know that this is going to happen, if I know that the ends are not going to be passing through, before I do the cut, I might have to do something I might have to do something like this. Instead of creating a cut, I'll select new body, select OK, hide my main body, go into one of these, press pull. Okay, not that one, of course, that one was fine. Press pull these. Okay, or I might select extrude and extrude these. So I get these to go through as well. So I do that. I'll do the same for this one, for example. I'll do the same for this one. And then I can go ahead, open this up. As you can see, they're passing through now. And cut. Make a cut. And the way I made a cut, if you guys remember, I can go into combine, select my target body, the big body, and in my tool body, I can select from here, for example. Okay. I can select cut. If I want to keep the tools, I can, but I don't need the tools. I can say that, and these three went through, as you can see. Okay, so that would be the way to make a geometric pattern, and there's a lot of different things that you can do with this. You can also play with the custom. All you have to do is create your own. Actually, let's do that. Let's create a custom one. Let's do a polygon. Okay. I didn't really make it that complicated. Let's do that. Let's say new body. Okay. Now we have our small polygon. We're going to pattern, geometric pattern. This is the face. Okay. Select custom, custom object. It's asking me for a perpendicular direction. So if I don't select that, all my hexagon prisms are looking at the side. I don't like that. So I select my direction. I can select from any edge. And there you go. I have a hexagon pattern. I can click rotation to rotate them. Okay. You can see that they're rotating. Let's look at it from the top. Maybe it'll be easier to see. Let's make it 15. Okay, you can see they're all rotating individually. I can create a size limit. Okay. So Fusion is very smart. It knows that this is a prism, so it's playing with it according to the settings. I can say U distance and V distance should be smaller. Let's say something like that. Maybe a little bit more. Okay, so that's my geometric pattern. Now, custom is sometimes more useful than what you have here because you get rid of this problem that we had in terms of the part going through. You can make your cylinders or squares, prisms longer, and that will solve that. Okay, so let's cut this. Let's cut this. Okay, and ta-da! That's it. So you can hide your original, and that's what you have. Interesting. Okay, so that's pattern. Okay, so that was the geometric pattern. Now, let's close all of these. Now we're going to do something different. Don't save, don't save. Okay, let's get rid of this one. Okay, now we're going to talk about emboss. Okay, Now, rib and weld, they're not very useful in terms of doing modeling. They're mostly useful when you're doing injection molding parts. So I'm going to skip that. You can, it's actually the part of an advanced course, but for now, you can discover them if you want. You can do everything that rib and web does using extrude. So we're going to talk about emboss. Now, emboss is very useful. And for that, I'm going to create a basic object. Okay, I'm going to extrude it. Actually, I want this to be a little bit wider. Let's do it like that. And I'm going to apply a fillet to one side. So we have a curved surface as well. Something like that. And let's say I want to apply something on the surface that is an emboss. So it's coming out from the surface. And I know what I want to apply. Actually, I'm gonna draw it. And I'm gonna do a few different examples, but to draw it, I want to create a new plane so I can draw it on that plane, then apply it to the surface. Okay. I want something like a capsule form, a slot. Okay. Let's do a slot. Something like that. Okay. I want this to wrap around the surface. Okay. Now, the easiest way to do this is using emboss. Okay. Now, as soon as I click emboss, a new tab opens on the right-hand side, as always. It's asking me a few things, which is important. Okay. Now, even though it's called emboss, you still have the option to create deboss, which is also called the relief. Okay. Now, this time we're going to do something that comes out of the main body. We're going to select our sketch. Okay. Face is asking me for the faces. I want this face. Okay. Now, as soon as I click it, you can see that we got an emboss. Okay. Now, for the depth, just so we can see it easier, I'm going to say 5. So it comes out of the body, and I'm going to say OK. Now, as you can see, this emboss is following the curvature of the body. Okay, this is very important because if you had made an extrusion and cut it, you would still not have this perpendicular shape to the face unless you cut it specifically. And it's very hard to cut something like a round face or an organic face like this. So emboss is very useful. I'm going to edit this emboss, edit the feature, and I'm going to talk about these. Now, the horizontal distance. Just because you have your sketch at a location doesn't mean that's the limiting factor. So if I click 5 in the horizontal distance, I can move the whole thing 5 millimeters to the left, even though my sketch hasn't moved. The same goes for the verticality. So if I say 5 for the verticality, I can move it down. And the emboss adapts to this movement. I can also create a rotation angle. I can also do it from here. I can say rotate it 10 degrees, and as you can see, the curvature follows. Now this is very useful, and it makes some stuff very easier, especially, I'll show you something. Now I created this weird emboss, okay? Now I'm gonna make this a much longer face, something like that. and I'm going to say create a rectangular pattern. Instead of object type, I'm going to say feature, okay? Feature. And I'm going to select the emboss, okay? And for the axes, I want to follow this edge, okay? I'm gonna pull it. I'm gonna pull it towards the end, and I'm gonna fill in between. Let's say 7, okay? So now I can create features like this, which is actually a very complex feature in terms of mathematics. But you can do it as easily. You can also do this as a relief. Instead of coming out from the object, you can say I want to go into the object, okay? And say okay. So you can do it as a relief. So this is, you would see this like on a toothbrush, for example, where you hold it. This is what you would see, okay? Now, I can also do fillets on this, okay? I can go and say, I want to fillet, I want to rule fillet, okay? I say all edges, I want to select the feature, which is the emboss, okay? Radius 1, so it fillets everything. And I say okay. Now, as you can see, it did one of them. But if I had put this fillet behind the pattern, and in this pattern, if I edit the pattern, instead of selecting a single feature, I select both the emboss and the fillet, I can get something like that. But I think I have to edit my type, as you can see. I need to edit the type. Sometimes it doesn't like doing adjust. Sometimes it wants something different. It doesn't like that as well. Let's try and do optimize. What does it say when I say optimized? Oh, it didn't even like that. Okay, let's do adjust, but let's play with the fillet. Let's say 0.5. It didn't even like that. When I click it, it says compute failed, no fillet edge found. Okay. Because of this complexity that is happening here, it had a hard time replicating this. But if we do optimized again, will it do it? No. Let's see if we can fix this. Let's see. It's not gonna do identical, I don't think. No. Let's delete this and try and redo it. Let's see what it's gonna do then. Command axes. Let's do the 3. No, it didn't like that. Sometimes this happens. There's nothing you can do about it because it's not only about your model, it's about the way Fusion computes. There's a workaround this, and I'm going to try that as well. I'm going to show it to you guys live. Okay, let's do this then. Let's do one at a time. Okay, let's say axes. I want this. I want that. I say okay. Then I'll do another pattern, another feature. Select my axes and do that. Now it doesn't like something that is going on. Now this might be because of the pull. So let's go back before we did the pull. And let's do an extrude. Yes, it's weird, but sometimes this happens as well. Now let's do a fillet, a rule fillet using this and 1mm rolling ball. Okay. Let's try and do it again. There's also another way, which I'm going to show you. But let's try these first. Okay, and this one. So I select the emboss and I select the fillet. For my axes, I select this one. Let's do 3 of them. No, it doesn't like that. Okay, so there's another way. Let's do it this way. Instead of doing this, not that. Instead of applying the fillet, I delete the fillet. Okay. Now I have this feature, and that feature is applied as an effect, right? So I say, okay. Now, what if I were to remove this? Okay, then it would work. How would I remove it? I could cut it. So how do I cut it? Let's say, can I do a split body? Okay, body to split. Splitting tool. Can I use this and this? Yes, I can, but I need to show you guys something else before I do that. I think. Let's select this one first. Okay. Okay. Then let's select that one. Body to split. This one. Splitting tool. That one. Okay. No. I want to split this. Body to split. Splitting tool. This one. It just goes through the edge. What if I don't extend it? No. What if I do extend it? Let's try that. Nope, doesn't like it. Okay, there's another way to do that, and I'll show you that. We're gonna get into surfaces, but just for the sake of the problem that we're having, and you will always have problems, I'm gonna show you something that is pretty good. Now, I deleted everything until my extrude, where I extruded this. And I'm gonna pull my history. Or no, I'm gonna go and click emboss, and I'm gonna say express feature. Okay. Now, as you can see, it expressed everything after it, but I don't want that. So I'm gonna say unspress, go and move this extrusion behind. Okay. Go and delete this extrusion then. I'll delete that extrusion. I'll move my history here. Then I'll extrude. Okay. 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 Now, so it doesn't allow me to move my extrusion. So what I had to do was re-extrude. What I can do is something very interesting, and we're going to get into that in next week in depth, but I can do something called offset face. And what I can do is I can uncheck my chain selection. I can choose these 2 faces, and I can extrude them as if I can offset them as a face with 0 distance. So when I say okay, I got this. I got this face. Now this face is awesome because you can use it as a cutting tool. So I'm trying to cheat Fusion. So I re-enable my emboss, okay? Then what I'll do is I'll do the fillet again. I'll do a rule fillet. I will select my feature. I will say okay, great. Then I will cut this. It's like removing it with a knife. I can say split body. I'll select body to split, and for splitting tool, I use my surface. Okay, say okay. I'll hide my splitting tool, and if I hide my body, I have this. Now, what I can do is I can go into rectangular pattern. I can select this instead of a feature. I can select it as a body. Okay, select my axes, pull it out to where I want it to extend, then increase the number. Okay, something like that. Okay. Now I have them, but they're all separate bodies, right? Then I can go into combine, select my main body as the target, and select my tools, the other ones, right? And select join. Select OK. Ta-da! And that's that. See, the fillet, or the way Fusion works, is it's having a hard time calculating these fillets when you're in a pattern. But there are always workarounds. And this is one such workaround. Okay, so that's emboss. Let's do a different type of emboss example. Okay, so let's create something. Let's create something with a more organic face, let's say. Let's click spline. Let's create something like that. Actually, let's close it. Like that. Okay, finish sketch. Let's extrude it. Okay, so like that. Then, let's create an offset plane. There. Okay. And let's sketch on this plane. Let's sketch on this plane. And let's write a text. Okay, this is going to be a difficult one for Fusion. Okay. Now, text is very easy in the sketch environment. All you have to do is write your text. Something like that. Okay. Decide on how high you want your text in terms of millimeters. Let's say 50 or even 60. Okay, that looks about fine. And choose your font. Choose Arial Black. Actually, let's make it a little bit smaller now because we chose Arial Black. Okay, and say OK. Now, as soon as you click OK, you have something that you can play with. You can move it around. But it's not a vector yet. So what we need to do is vectorize it. What you do is you right-click your text and say explode. Now, not all font types explode, okay? Some will give you an error. That has to do with the font. There's nothing you can do with it. But some will do. And once you explode it, you'll get this vector type. Okay, this vector is basically a sketch made of lines and arcs. Okay, now let's try and emboss. Okay, we finish our sketch. We go into emboss. We select our sketch profiles. Okay, and select our face. And ta-da! So you have your writing on the face. Now, the amount of depth that you create might create problems after a while. Okay, but usually, I mean, if you look at this, it's starting to create problems as the font is closing onto itself. So you need to make adjustments according to where you're placing it. Let's make it 2 millimeters for this example. Okay. Okay, so that's also a very good way to be able to write text on curved faces. Okay. Now, let me show you what happens when we do it on a sphere. Let's create a sphere for the sake of argument. Let's create one that is from a primitive. Okay. Let's create an offset plane. Okay. And this offset plane will do a sketch. Okay. And for this example, let's create something like an ellipse. Okay, something like that. Say OK. Go into Emboss. Select your sketch. For your face, you select the outside of the sphere, and once you start extruding it, you will get this. Now, you have to watch out because the control placement on a sphere is problematic in terms of the vectors that go into its surface. As you can see, everything seems to be tapering, okay? Because there is no single curve. It's all compound curves. So you need to watch out for where your sketch is in relation to your object, okay? I mean, I need to be able to center this sketch to this sphere if I want it controlled, right? Even though I can move it from the distances, I can give it a horizontal distance or a vertical distance. I don't know where on the sphere it is exactly, okay? So you need to be aware of that, okay? You can also do a deboss like that, and create small Among Us characters this way or something. Okay, so that's Emboss. Okay, now let's close this. Let's actually, let's actually work on this because it's a good example of something that looks like it's from a product, right? Now let's say I have some points that I need to select and design for a fastener. That means a screw or a bolt or a nut, okay? So I'm going to draw some fastener placements, okay? Now there are a few ways to do this, but Fusion makes it very easy with the hole command, okay? Now, to be able to use the hole command, you need to tell Fusion where to place the holes. And the easiest way to do this is with point. And you do that in a sketch. So I'm going to sketch on this plane. And I'm going to look at it from the top. Okay, and I'm going to create some points arbitrarily. Okay, so I put someone here, put one here. Okay, and I'm going to say I want to use these points as the placement for my holes, and I'm going to say okay. Now you can see the points inside of the sketch, this sketch. And to use the hole command, you select hole, or you're going to create and then go down and select hole right there. Okay. And as soon as you select hole, you get this tab on the right hand side where it asks you to select the sketch points. So I'm going to select my sketch points. Okay. Then, because the current adjustments are too big for this body. It's giving me an error, but we're going to fix that. Now, there are different hole types. Now, the first thing you have to understand is the hole types. What type of a hole are you opening? And for this example, I'm going to open a counterbore hole, okay? Now, as soon as I select that, Fusion has given me a preview, okay? Now, the counterbore setting doesn't seem to be right, so I need to fix that. Now, this hole needs to be a clearance hole, okay? So the screw goes through. And the bottom needs to be flat, not pointed, okay? Now, I have some options down below where I can select ready-made settings. And for this example, because in Turkey we use the DIN standard, which is a German standard, I select DIN first. Then I select the type or the size of the screw, which I'm going to select, let's select the metric 5, okay? Then I'm going to adjust the counterbore, because I don't like the counterbore height. Now, if you look at it, it's not allowing me to adjust the counterbore height, okay? So I can pull and make the screw longer, but I can't seem to adjust the counterbore height. One way to fix this is, if you know what these dimensions are now, it's 10, 5.5, 5.5, these three. I can go and say custom counterboard size, okay? Now, I can do that by going into simple, okay, and then entering my values, which is important because I need to change this. I need to make this something like 10, so the counterboard actually goes into the product. Make it like 15, which is actually pretty good. Okay. Now I can say I want the screw to go all the way to the bottom, and I can say OK. Now I have my screw mounting places. Usually in products, what you have is you have a fillet around this. So I go into fillet, I go back to normal fillet, I select these edges and I say 1 millimeter, something like that. It's not done yet, but I can do this for all of them. Okay. Something like that. I say OK. Then I go back, select fillet again, and choose this time. Okay. So it's more realistic. Okay. Instead of doing it this way, you could have done it the other way as well. It will make a slight difference, but for this example, this is fine. Now I have a hole that my screw can go through. Okay, so with the hole command, you can control your holes. Now, the next thing we're going to learn, which works great with the hole command, is the thread command. Okay, when you go under create, there's this thing called a thread. Okay, if you had selected, maybe I should show you guys that because it might not have been clear. Let's go back to our hole command, edit feature. If we had selected tapped hole, which means it has threads in it, then Fusion would have created a hole with threads in it. Now, you can see the threads on the preview. You can have these threads in two ways. You can have it as an image. There is no modeled thread here, which actually saves performance on your computer. You get more performance that way. But if you want to see the threads, you can say modeled. Okay? And if you click OK, Fusion will actually model those threads, and now it's modeled. Okay, these are real size threads. But as you guys remember, we didn't want a tap tool, we wanted a finish tool. Okay, we wanted a clearance hole. It's called a clearance hole. That screw goes through without having any kind of relation with the wall. But let's say after the fact you wanted to put threads in it. So what you do is you're going to create and you select threads. And it gives you a couple of options that you can change. First, it's asking you which face do you want to apply the thread on. Now I'm going to select the internal one. Do you want it modeled or not? Okay. Do you want it full length, or you can control the length? Okay. You can say I want the thread to start from here. Okay. And go towards somewhere that you decide. You can say like that. So if we were to, let's say, have a screw that only attaches on the bottom, we could do this. So you can see it's only on the bottom now. You can say full length. Then you can say which profile thread. Now ISO is fine, thin is fine, but these are different type of threads that you can find in the marketplace. Acme, ANSI, BSP, GB, Ghost, or GIS are not usually used in Turkey. You have very few places that use them. But ISO, which is the International Standards Organization, is very similar to DIN. And most of the time we use ISO metric profile. So that is selected. Then we select the size. As you guys remember, we selected a metric 5 when we were doing the hole. But if you want to change it, we can say 6, and the hole will get bigger. Fusion will make that change automatically. Okay, but because we did a counter bore, we would also need to change the outside cylinder. We're not going to do that. We're just going to say 5 and say OK. Now there was this setting that I didn't check, which is quite important. Now there's this thing called remember size. Okay, if you check this, every time you open the thread, it will open with these size settings. And this is very useful if you're working on a complex part and you need to do a few of these. Okay, you just click this and it always opens up with these settings. For this example, I'm not going to do that. I'm going to say cancel. Okay, so we have a hole with a thread. Okay, and the other ones are holes with the clearance. Okay, you can check this easily if you go and select your measure tool. Come here and measure. Actually, you have to unclick everything, then select the cylinder. You will see that it has a diameter of 5.02. But if you measure the one with the threads in it, it will be smaller, okay, because it has the threads in it, so it can hold the screw. Let's close this. Okay. Now, why do we do this? Why do we make the threads or make it a clearance? So, well, there's a feature in Fusion. Actually, it's been made much better now, but when you go into insert, there's this thing called insert fastener. Okay, and if you click that, Fusion will open up a insert fastener dialog box where you can choose your own bolts, nuts, or washers, so you don't have to model them. So we're going to select the bolt now. We're going to select count hex socket head bolt. Then we're going to say we want hex socket head cap screw. That's the most standard cap screw. We're going to select that. And Fusion's showing me a small preview. Look at that. Okay. Now, when I come into my hole, Okay, Fusion changes this preview according to what I have in my model, which is very nice. Okay, so I'm gonna select the internal face of this hole. So Fusion adapts my screw, and I'm gonna click it. Then Fusion is asking me for a placement. So if I select this face, Fusion puts it there. Okay, see this green check mark that says it's done. Okay, now this insert fastener is actually very simple in terms of what it has. Position is selected automatically as you move towards your hole. Okay, even if it's threaded or not threaded, Fusion will catch it. Okay, let's actually go to this one. Okay, you see? Now, if you guys remember, these first two holes are not threaded, but this one is. Let's see what happens when I select this one. Okay, now as you can see, Fusion put two screws. It put one on the beginning and one on the one I selected, because there's this thing called select similar. So what Fusion does is Fusion goes through the model, it inspects the model in the background, and selects all the holes that look identical to each other and puts screws into them as well. Okay, and this way you save a lot of time. Now, here we have some customization options, like the nominal size. It says auto because it's getting that from the hole. Length, which we can change, we can make it much longer. Let's make it 50 millimeters, so the screw comes out from the bottom. We want steel, or we want brass, whichever steel we want. Let's select the toughest bolt. Finish, we can say I want it black. I want the screws black. Okay, and we can say OK. Now, as you can see, Fusion has created my bolts. Okay, they put them in the right spot. Not only that, it created a joint automatically. You can see it under joints here, 3 rigid joints, and it created them as a fastener group. Now, this is something new. There's a fastener group right here. Okay, so it's different than using some kind of component. It has its own tree item, okay, and it has its own icon. Now, you're going to be using this in the next in-class assignment, so I would like you guys to practice this. Okay, as the last thing in this week's lesson, I'm going to talk about the canvas. It's going to be a very short talk because you guys started using it. But there's this small thing that you guys need to remember, and I'm going to show you that. I'm going to insert a canvas item on a new design. I'm going to insert it from my computer. I'm going to say open. I'm going to select the face. Okay. And just like you guys did, I'm going to say OK. Now, I have this item pasted, but there's a problem, and I can see that problem as soon as I try to create a sketch on this plane. If I were to create this item, let's create a line right there. How long is this line? Let's measure it. 11.9 millimeters. But this lamp, I know, is 360 millimeters high. So my scale isn't correct. Okay? So I'm going to finish this sketch and I'm going to show you guys something. I'm going to delete this. If you go into your canvas and if you right-click your canvas, there's this thing called calibrate. Okay, this is very crucial. If I click calibrate, Fusion asks me for, and if you hold your mouse steady, it says pick the first point on the canvas plane. So what I'm going to do is I'm going to zoom in. I'm going to click this point, and if I wait, it says pick the second point on the canvas plane. So I'm going to go up to my measurement. As you can see, there's this measurement that I put on this drawing. So I'm going to pick the top point. Okay. Now Fusion is giving me a distance. Okay, you can see down below Fusion is giving me a distance. Now instead of this 12.05 or whatever, I'm going to type in 360. Now, as you can see, the image zoomed a lot. Now I have a somewhat accurate canvas. And if I go into this canvas and if I sketch on it, and if I draw a line, just like I did last time, something like that, then if I measure this line, my line is kind of crooked, but you will get the point, you will see 358.2 millimeters. So I'm actually very close to the original size. Now, there's this thing in Fusion that you need to be able to use, and it's very helpful. Okay, it's called the help guide. Okay, if you wait on any icon and then read what it says on the pop-up box, especially what it says down below, there's this help menu, and I'm going to open that up. Okay, in this help menu you have articles about what you're working on. Okay, it's called guidance. Okay, now in this guidance there are some helpful things that it talks about. It talks about everything about what you're doing, but there are these helpful things. And for the canvas, the most helpful thing is written down below under tips. Okay, it's right here, tips. It says you can import PNG, JPEG, which are the same thing, TIFF and TIFF, which are the same thing. Okay, so you have 3 types of files that you can use as a canvas. Now, out of these files, PNG makes the most sense in terms of size, file size, and quality. Okay. Now, however, the PNG that you bring into Fusion needs to have a high resolution if you want to zoom in and select a calibration point. Okay, if it doesn't have a high resolution, you will get this. So use the learning panel guidance. It shows you great tips for items that are not explained in the pop-up boxes, because in the canvas pop-up box it doesn't tell you which type of files you can import. Okay, so now you know how to use a canvas properly. You can always edit your canvas back. Okay, you can change its opacity, of course. However, the most important thing isn't here, it's under calibrate. Okay, so you will use that in the next class assignment as well. Okay, that's it for this week's. I'll see you guys in class.